Hello, am I audible and is my screen visible? Hello, hello, can anyone let me know if I'm audible and if my screen is visible? Okay, thank you. So good evening everyone, welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this session we will discuss some practice problems on week 10 topics. In week 10 clustering was covered, so I will discuss some practice problems regarding clustering methods or clustering algorithms, and I will also try to answer your questions and queries. So if you have any questions or queries regarding the topics covered in this week's video lectures, please feel free to ask me. So I will start solving some practice problems, and then if you have any questions or queries, you can ask me later. So this is the first question. Suppose you have a single cluster of data points. The data points are -2, -2, -1, -2, 2, 1, 1, 2. These are the 4 data points. Find the data point x which has the highest average L2 distance with respect to the other points. So to find the data point x among these 4 points, which has the highest average L2 distance with respect to the other data points. So these are the 4 options, and each option corresponds to one of the 4 data points that are given in this question. So L2 distance is basically the Euclidean distance. You can write your answer in the chat. So has anyone calculated this answer? So in this question, you have to find out the point x among these 4 points given, which has the highest L2 distance with respect to the other data points. So basically, you have to take every point. For example, you first take this point, first point -2 -2, and find out the distance of this point from all 3 points and add them up. Or you have to take the average of that. So the L2 distance from -2 -2 to 1 comma -2 would be this L2 distance would be -2 -1 whole square plus -2 plus 2 whole square. So there would be 3 square plus 0 for 3, it's 9. So similarly, you have to find out the average distance to from -2 -2 to 2 comma 1, and then from -2 -2 to 1 comma 2. So you have to find out L2 distances from -2 -2 to all other 3 points, and then take the average of those 3 distance values that you get. So that would give you the average L2 distance for -2 -2, and similarly you have to do this for all 3 points, all 4 points, and from that you have to take the point for which this value is highest, the average L2 distance is highest. So this is, you just have to calculate the distance values using this L2 distance formula, or basically the Euclidean distance. You have to find out x1 minus x2 square plus y1 minus y2 square. So as I have shown, the distance from -2 -2 to 1 comma -2 is 9. Similarly, you have to find out for -2 -2 to 2 comma 1 and -2 -2 to 1 comma 2, and then take the average. Then again you have to take this point and find out the distance with from -1 -2 to all other 3 points, and take the average of that. And you have to do this for all 4 points, and then you have to find out which has the highest value. So this is not very difficult question. You just have to find out this L2 distances, and then you have to take the average and find out the highest value. So if you compute this in this manner, you will get option A as the correct answer, -2 -2. Is there any questions or doubt regarding this problem? Okay, then we can move on to question 2. Which of the following statement is or are not true about k-means clustering? So there are 4 options. Multiple options may be correct here. First option is it is an unsupervised learning algorithm. Second option is overlapping of clusters is allowed in k-means clustering. Third option is it is a hard clustering technique. Fourth option is K is a hyperparameter. So which of these following options is or are correct about K-means clustering? So you have to find out which options are not true. I've, there are no answers in the chat yet. So the correct answer here is there is only one correct option which is not true about K-means clustering. This one, option B. Overlapping of clusters is allowed in K-means clustering. It is not allowed. So that's why it is the correct answer for this question, because you have to find out which is not true. Regarding first option, it says it is an unsupervised learning algorithm. K-means is certainly an unsupervised learning clustering algorithm. And second option is third option is it is a hard clustering technique, which is also true about K-means clustering. The clusters are hard clusters, not soft clusters. So every point belongs to only one cluster. In case of soft clustering, a point can belong to different clusters, so it would have membership values for different clusters, but in K-means it is not allowed. It is hard clustering. And last option is K is a hyperparameter, which is again true. K is a hyperparameter which you have to choose. There are many ways of choosing that, but you can choose based on the domain knowledge of that task that you are trying to solve using K-means. So this is also correct. So the only option which is not true is option B, so that's why it would be the correct answer here. Now question 3, which among the following is or are some of the assumptions made by K-means clustering assuming Euclidean distance measures? So generally in K-means we use Euclidean distance measure, so you have to assume that we are using Euclidean distance measure between the points for the K-means clustering. So which of the following is or are some of the assumptions made by K-means clustering? 4 options are there. Clusters are spherical in shape. Clusters are of similar sizes. Data points in one cluster are well separated from the data points of other clusters, and there is no wide variation in density among the data points. So which of these following is or are some of the assumptions that are made in K-means clustering assuming Euclidean distance measure? You can write your answer in the chat. So Dr. S. Radhakrishnan Srivallabhadev says option C, which is data points in one cluster are well separated from the data points of the other clusters. Anyone else? Mishti Pandey says option C, and Raju Tellakula says option D. Murapaka Srinivasa Rao says option A and B. The correct answer, the correct options are A and B. So these are the two straightforward assumptions that are certainly made by K-means clustering. Because in K-means clustering generally Euclidean distance is used, and so because of Euclidean distance, clusters would always be of spherical shape. So cluster, it assumes that clusters are of spherical shape by using the Euclidean distance measure, because the Euclidean distance measure is something like this. This is the distance, Euclidean distance between 2 points x1 y1 and x2 y2, and which is very similar to the equation of circle or sphere in case of three-dimensional data. So it always assumes that clusters would be spherical in shape, but it might not be the case in all the examples that clusters would be spherical. If the clusters are not spherical in shape, then K-means would work very badly in that case. It would be very poor in finding out the clusters. And option B says clusters are of similar sizes, and this is also right because it uses Euclidean distance measures. So it basically assumes that the clusters would be of similar sizes. So for any new test point, if you want to find out which cluster it belongs to, so given a test point, it would just find out the distance from the centroid of all the clusters, and the closest centroid would be assigned as the cluster for that new test point. So that's why it assumes that clusters would always be of similar sizes, and which again might not be true in many of the clustering problems. In those cases it would not work. K-means would not be very good at finding out the actual clusters. So these are the two assumptions that are made, and the option C and D, it doesn't assume anything about these things. That option D says there is no wide variation in density among the data points, so it doesn't give any importance to density of the data points. That's why we have different set of algorithms called density based clustering algorithms like DB-scan, which has been taught in the class. So the K-means doesn't give any importance to density, but which might be necessary in some cases, but the density of the data points are much more important than assuming that the clusters are spherical or the clusters are of similar sizes. And the third option says data point is in one cluster are well separated from data points of other clusters. So this is also not an assumption made by K-means clustering. It doesn't make this assumption that points would be separated, well separated. So points might be overlapped also. In that case it would not work very well, but it doesn't assume that it would be well separated. So that's why the options A and B are the two correct assumptions that are made by K-means clustering. Now question 4. Considering single link and complete link hierarchical clustering, is it possible for a point to be closer to the points in the other clusters than to the points in its own cluster? If so, in which approach will this tend to be observed? So generally we want the points in same cluster to be closer to each other than the points in other clusters. But is it possible that in case of single link or in complete link, that points in its own clusters are not closer to the point than the points in the other clusters? Is it possible? Then in which approach, single link or complete link, it happens? It might happen. 4 options are there. No, that it doesn't happen. Second option is yes, in case of single link clustering. Third option is yes, complete link clustering. And fourth option is yes, both single link and complete link clustering. Pratik Tiwari says option B, single link clustering. Aditya also says option B. So the correct answer here is option D, that it can happen in both single link and complete link hierarchical clustering. So in case of single link, it might happen in case of two parallel chains where many points are closer to the points in the other cluster than 2 points in their own cluster. So consider this. So this is one chain and there is another parallel chain. So because of single link hierarchical clustering, these points would be merged to one cluster like this. So each chain would become one cluster, but you can see that for this point is closer than this point. Let's say so a point in another cluster is closer than the point in its own cluster. There are some points in its own cluster that are closer to it, but there are also some points which are not closer to it than a point in another cluster. So for two parallel chains, it might happen that points in other clusters are actually closer than points in its own cluster. And this is an example in case of single link. And in case of complete link, so it's much more easier to think about, because in case of complete link, we're measuring the we will merge the two clusters based on the complete link distance, or the maximum distance between a pair of points where one point belongs to one cluster and another point belongs to another cluster. So if this is one cluster and this is another cluster, so we use these 2 points. Let's consider it like this. So this is one cluster and this is another cluster. So not here, let's consider here. So this point for this point and this point. So in case of complete link, we consider this distance as the distance between the two clusters, but these 2 points are much closer than the distance between this point and this point. So because in case of complete link, we define the distance as the maximum distance between 2 points in two different clusters. So that's why it is much more intuitive that it might happen in many times in case of complete link hierarchical clustering. So in both the complete link and single link clustering, it might happen. So is there any questions or doubts in this question? So now question 5. In the Keor algorithm, Keor clustering algorithm, which is clustering using representative points. Representative points of a cluster are moved a fraction of the distance between the original location and the centroid of the cluster. Would it make more sense to move them all a fixed distance towards the centroid instead? Why or why not? So if you have gone through the video lectures about Keor algorithm, so first we find out the centroid and then we find out the representative points which we want to be near the border of that cluster. So if this is the cluster, this is the centroid, we want we first find out these border points and then we shrink these points towards the center, shrink these border points towards the center, and these points, this one, this one, this one and this one, these points and also this one points become our representative points for the next level of clustering, next iteration of the clustering. So and this shrinkage is done so a fraction of the distance, shrinkage is done by a fraction of the distance, not by a fixed distance for every representative point. So would it make sense to do it a fixed distance for every border point or the boundary point? Aditya is asking, can I get these PPTs and all previous sessions given us? Yeah, Aditya, so these links for the video lectures and also the links for these presentations or the question answer PDFs are also uploaded. So you can get all these links from the course web page. So in the left hand side there is a tab week 1, week 2, week 3. At the end of those all the weeks you can find out the problem solving session link. From there you can find out all the recorded video lectures and also these PDFs. I have not received any answer for this question yet. So the correct answer here is no, that it would not be better than the fraction shrinkage. Fixed distance shrinkage is not better than the fractional shrinkage because the approach will not be effective against outliers. So for the outliers, the distance from the centroid to the outliers are much more than the distance from the non-outlier points, and so in that case we want the distance to be shrinked for the points which are farther apart from the centroid. So moving them a fixed distance would not be very effective in case of outliers. So moving representative points towards cluster centroids helps in overcoming the effects of the outliers. In the proposed approach, moving only a fixed distance towards the centroid would be less effective against the outliers, since the distance between the outliers and the centroid may be much larger than the distance between the other points and the centroids. So moving a fixed distance would not be helpful in case of overcoming the problems with the outliers. So that's why we use this fractional shrinkage. That's why the shrinkage would be more for the points which are farther apart. Now question 6. Suppose while performing DB scan we randomly choose a point which has less than mean points number of points in its neighborhood. Which among the following is true for such a point? Four options. It is treated as noise and not considered further in the algorithm. It becomes part of its own cluster. Depending upon other points, it may later turn out to be a core point, and depending upon the other points, it may be density connected to other points. Pratik Tiwari says option D, which is depending upon other points, it may be densely connected to other points. Anyone else? So the correct answer here is option D. So we randomly choose a point which has less than mean points number of points in its neighborhood. So if it has more than or equal to mean points number of points in its neighborhood, then it is certainly a core point. And if it has less than mean points number of, then it might be a noise point, might not be a noise point. It might also be a border point or the density connected point. So it would be a noise point only if there are no, it has mean points lesser than mean points number of points in its neighborhood, and there are no core points in its neighborhood. And if it has less than mean points number of points and in its neighborhood, and there is at least one core point in its neighborhood, then it would become a density connected point or the border point. So depending upon the position of the other points, it might become a density connected point to the other points. Which of the following can act as possible termination condition for k-means? Possible termination conditions for k-means. There are four options. For a fixed number of iterations, we can run the k-means and then we stop it. Option B says assignment of observations to clusters does not change between iterations except for cases with bad local minimum. Option C says centroids do not change positions between successive iterations, then we can terminate it. Option D says terminate when RSS or residual squared error, which is basically like the squared error from the centroid to all the other points. Basically, it's sum of distance from the centroid to all the other points. So terminate when this RSS falls below a threshold. So these are the four options, and multiple options may be correct here. So which of these following are possible termination conditions? Aditya Johan says option A only, and Dr. S. Radhakrishnan says A and D. Pratik Tiwari says option B. Okay, so I've got different answers in the chat. Durga Prasad says D. Anyone else? So the correct answer here are all four options. So first option says fixed number of iterations. It is certainly possible that if you know that or if you have experimented with the algorithm on that dataset, that after a certain number of iterations it always converges, the clusters always converge. In that case you can set it as the termination condition. So this is possible. Second option says assignment of observation to clusters does not change between iterations. So after every iteration you reassign points to different clusters based on the distance. So for every point you find out which is the closest centroid and then you assign that cluster to that point. So if between successive iterations, if the cluster labels do not change for any of these points, then the centroids would not change. If the centroids do not change into successive iterations, then it would not change, or it would also not change the next iteration. So this is also a valid termination condition. And the third option is very similar to the second option actually, that centroids do not change. If the assignment of the cluster labels to the points do not change, then the centroids would also not change. Centroid would simply be the average or mean of all the points assigned to that cluster. If the assignment of cluster labels do not change for the points, in that case centroids would also not change in successive iterations, and it is certainly a possible termination condition. And fourth one is terminate when RSS falls below a threshold. It is also possible that RSS is the, generally we do not use any loss value while running the KNN or implementing the KNN algorithm, but while doing the KNN iteratively, we actually reduce this residual sum of squares, which is simply the distance, sum of the distance from the centroid to all the points assigned to it. So we actually reduce that while doing the k-means algorithm. So if this error value, this RSS error value falls below a certain threshold, we might not want to continue because of time constraints or something. In that case, you might also terminate like this. So this is also a valid termination condition. So all four options are possible termination conditions for k-means algorithm. Now question 8. In the figure below, if you draw a line at, so this is basically a dendrogram generated by a hierarchical agglomerative algorithm, clustering algorithm. So these are the individual points A, B, C, D, E, F. These are the 6 individual points, and then we start merging them based on the similarity or the distance between the points, and we have until we reach only one cluster. So that's why it's called hierarchical agglomerative clustering. We agglomerate or combine clusters iteratively. But if we want to get a certain number of clusters, we have to stop at some point. If we stop at this yellow horizontal line of this dendrogram diagram, so how many clusters we will get from this? Pratik Tiwari says 2 clusters, which is option B. Dr. S. Radhakrishnan says option D, which is 4. Aditya Chauhan also says option D, 4. So the correct answer here is option B, which is 2, because if this is the cutoff line that we are using to get our clusters, so at this horizontal line we have got 2 branches. This is one branch and this is another branch. So this branch has 4 elements, this branch has 2 elements. So these are the 2 clusters. This is one cluster and this is another cluster. So you have to check at this horizontal line how many branches are there. This is one branch and this is another branch. So this is one cluster, this is another cluster. So this first cluster contains D, F, E, C, and second cluster contains A and B. So we will get only 2 clusters if we cut the process, hierarchical clustering process at this yellow horizontal line. So correct option would be option B, which is 2.
What will happen if you cut at 0.5?
0.5.
Yes.
I mean, you can't exactly cut off at a point where we are just merging these two. Either you have to cut off at this point, from let's say here you have to, or here. Either you cut off after merging 2 clusters or before merging those clusters. So if you take this line, in that case this is one cluster you have got, this is another cluster, this is another one, and this is another one. So 1, 2, 3, 4 clusters you will get. So basically you have to check at this point how many branches are there. If this is where I am cutting off, so this is one, this is one, this is one, this is one. These are the 4 clusters you would get.
Okay, thank you.
Now question 9. In which of the following cases will K-means clustering fail to give good results? Pratik Tiwari asks 1. Why we count E and C? Pratik, for which line are you answering about, this line or the second line that I drew?
The second line you have drawn for 0.5.
Yeah, so at this line only one margin, 2 margin have margins have taken place. This is one margin and here is another margin. E and C have not merged yet.
So we will consider as an individual.
They are individual clusters because we start with individual clusters only, isn't it? All these points are in their own clusters, and at this straight line we have not merged E and C yet to any of the clusters. So this would be one cluster, E and C would be on their own clusters, and A, B would be another cluster. So question 9 is in which of the following cases will k-means clustering fail to give good results? There are four options: data points with outliers, data points with different densities, data points with round shapes, data points with non-convex shapes. So in which of the following cases k-means clustering will fail to give good results? It might there may be multiple correct answers in this question. Pratik Tiwari says D. Any other answers in the chat? Riddham Sadhana says option B and D. So B is with different densities and D is with non-convex shapes. And Dr. S. Radhakrishnan says option B, which is data points with different densities. And Durga Prasad says A and D. So data point with outliers and data point with non-convex shapes.
Just a question. Is saying different density means different size in clusters?
No, different densities means here this density of the point. There are many points in a small region, and then there are lesser points in this region like this. So density of the points in a specific or unit area, you can say. Srinivasa Rao says A and B with outliers and with different densities. Anandan says A and D, which is outliers and non-convex shapes. So I've got many different options, answers in the chat. So the correct answers are A, B and D. Only C is not the correct answer. All the other options are correct because first option says data points with outliers. So it is a well-known problem for k-means because k-means works only using the distance metrics, and specifically Euclidean distance is used. And so it might happen if for outlier points it would classify it to be, or it would level that outlier point into its closest cluster, but it might not be a point in that cluster. It might only be an outlier. So it's a known problem for k-means that it cannot detect the outliers because it just uses the distance. So every point would be assigned to its closest centroid or the closest cluster, so it doesn't detect the outlier points. But if you go through the density based clustering algorithms like dbscan, it detects points and categorizes points in different categories like core points and density connected points or border points, and finally the noise points. So it can detect the noise points which cannot be detected in case of if we use k-means clustering. And second option is data points with different densities. So again, k-means doesn't give any importance to the density of the data, and this is a drawback for k-means clustering, and that's why we have this dbscan and other density based clustering algorithms. So density is also important because we need to check how densely the data points are packed in a specific region. Based on that we can create clusters, but it doesn't, it just checks the distance from the centroids, and based on that it assigns the clusters. So it doesn't check the densities of the points or the nearby regions. And option C is not correct, because data points with round shape, it does really well if the data points are with round shapes. If the data points are round shapes or spherical, that is the clusters are spherical or round shaped, in that case it works very good, because it uses the Euclidean distance, and Euclidean distance is similar to the equation of circle or sphere in case of higher dimensional data. So that's why if we know the clusters are of spherical shape or circular shape, in that case k-means would be the best choice. And last option is data points with non-convex shapes. So again, if the data points are of non-convex shapes, like this is one cluster, this is one cluster, and this is another cluster, so it cannot detect this as one cluster. It's because this is a non-convex shape of a cluster. So convex should be like this. So that's why it cannot detect non-convex shapes of clusters, which can be detected using other hierarchical methods and also using density based clustering. So this is but density based clustering methods are much more superior to k-means clustering, that it can detect those non-convex shapes, because it tries to find out regions with high density points. So A, B and D, these are the three correct answers. Satya Narayana Rao says, then how many fraction of marks will be allocated if 2 are correct, calculated instead of 3? Yeah, in case of assignments you get proportionally. If you mark 2 correct answers out of 3, you get possibly 66% of the marks for that question. That way, I think that way it works. But in case of final exams or something, I'm not sure. In case of assignments, it might be true. You can check in the portal itself in the assignments. Now question 10. Consider the following 3 points: 1, 1, 2, 5, 6, 8. So we want to apply Barch clustering algorithm to these set of points. We just want to compute the Barch cluster features, or the CF, which is called in case of Barch. So if we want to compute the Barch cluster features for this cluster, so this is one cluster. These all 3 points belong to only one cluster, and we want to find out the cluster feature for this cluster containing these 3 points. What would be the Barch cluster feature? So Barch cluster feature is a 3 tuple. If you have gone through the video lectures, so you have to compute this 3 tuple for this cluster containing these 3 points. Pratik Tiwari says option C, which is 3, 9, 8, 131. Okay. Has anyone else computed this? So the cluster feature is a 3 tuple where the first element is number of points in that cluster. So there are 3 points in that cluster. So in the 3 tuple, first element would be 3. A second element is simply the vector sum of all the points in that cluster. So there are 3 points 1 1 2 5 6 8. You have to just add these 3 points as vectors. So you have to find the vector sum. So the vector sum would be so it would be 1 plus 2 plus 6 comma 1 plus 5 plus 8. So there would be 9 comma 14. So it would be 9 comma 14. And the third and the last point is the squared sum of the points. So squared sum means there are 3 points 1 1 2 5 6 8. So squared sum would be 1 square plus 1 square plus 2 square plus 5 square plus 6 square plus 8 square. So this is for the first point, this is for the second point, this is for the third point. For all the points you have to add those sum squares, sum of squares. So if you compute this, it would be 131. So this is the 3 tuple that you will get. So option C. So Pratik Tiwari has written the correct answer in the chat. So this is these are the 3 features in the cluster feature vector. First one is number of points, which is 3. Second one is the vector sum of all the points in that feature, and third sum is sum of squares of all the points in that cluster. So option C is the correct answer. Now question 11. So consider the similarity matrix given. So there are 6 points P1, P2, P3, P4, P5, P6. So for these 6 points, this similarity, these are not distance matrix. This is not a distance matrix. This is the similarity matrix for these 6 points. And you have to find if you use the hierarchical clustering algorithm, a single link hierarchical clustering algorithm. In that case, what would be the dendrogram created or hierarchy of the clustering created by this single link clustering algorithm? So this is a similarity matrix. So the higher the value, the points are more similar. Raju Tellakula says option D. Srinivasa Rao says option D. Pratik Tiwari says option D. So I've got 3 answers in the chat. All are saying option D. So as it is a similarity matrix, it is not a distance matrix of the points. So it is a similarity matrix. In every iteration you have to find out the pair of points for which the similarity value is highest among all the pairs here. So first you have to ignore these diagonal elements, because the similarity between P1 and P1 would obviously be 1, between P2 and P2 would obviously be 1. So you have to ignore these diagonal points. So ignoring those diagonal points, now you have to find out the highest similarity. So if you go through this table, I think the highest similarity is 0.85 at first, which is between this P5 and P6. So first P5, so first you will write P1, P2, P3, P4, P5, P6. So first we have to merge P5, P6 because these two are the most similar points.
P2, P3 is
P2, P3.
Oh sorry, this 0.95 is already there now. Yeah. So 0.95 is the highest similarity from this matrix. So P2 and P3 would be merged first. After 0.95, then the second highest similarity value we can find out is, I think, 0.085. So now P5 and P6 would be merged. And after merging P5 and P6, the next highest is I think 0.75, which is between 0.8 is there. Yeah, 0.8 is here. So which is between P4 and P5. So P5 has already merged with P6. So that means I have to merge P4 with P5 and P6. And after 0.85, the next would be this 0.75, and 0.75 is between P3 and P4. P4 is already merged with P5 and P6, and P3 is within P2. So these two clusters would be merged. And finally only one point is there, so it will be eventually merged with rest of the points. So this is the structure. Sorry, this one. Yeah, this is the structure, and it is, I think, option D. Yeah. So as it is single link clustering, so in case of complete link it might be different, because in complete link we try to find out the distance, highest distance or the maximum distance between two clusters in case of merging. In case of similarity, it would be the lowest similarity we will take, but in case of single link, we take the closest 2 points from the two clusters. So the highest similarity values from the two clusters we would take. That's why in case of complete link, the dendrogram might be different, but in this case it would be option D for single link clustering. So option D. Yes. Yeah, so these were the practice problems that I wanted to discuss in this live session. So now if you have any questions or doubts regarding any of the problems solved today, you can ask me. Fourth question. What was the fourth question? In fourth question, I already mentioned that for complete link, we always try to check the distance between the two farthest points in the two clusters. So for these 2 points, the distance might be smaller than the distance between this point and this point, isn't it? Because we try to merge two clusters for which the complete link distance is lowest, but complete link distance basically means that the 2 points are farthest apart in two clusters. So that's why these 2 points might be very close to each other, but they are situated in two different clusters. But this point is very far away from this point, which is in its own cluster. So that's why it can happen very frequently in case of complete link. But in case of single link, it might not happen always. But in case of if we take two parallel chains, in that case, in case of single link also it would happen. Is there any other questions or doubts?
One in the RAND index, there is reference clustering. Reference clustering for which we compare the model cluster.
RAND index, I have forgotten the actual formula. It is a plus b by nc2,
That's it. Yeah.
where a is, I think, a is the number of times two pairs are appearing in the same cluster, and b is number of times the number of times pairs are appearing in two different clusters. Yeah, that way you
And they are
compute.
compared with one that is model predicted cluster and another with the reference.
So for two different clustering methods we compare it.
Right. So I'm saying if the reference clustering it can be said as a true labels or what is it reference clustering?
So we basically compare two clustering methods there. That clustering method 1 and clustering method 2, and then we compare how close are they. How close are the not exactly accuracy we want to compare, because two clustering methods might give different results, but we try to compute how close those clustering methods are. So RAND index should produce, I think, high. It might. I think it would produce higher value if the two clustering methods are very similar in the output, and if they are very different in the output, different points are in different clusters. In case of two different methods, then the RAND index value would be lower.
So I mean I can say RAND index can be calculated without having a true label.
Yeah, it can be. I mean, if you have the true labels, then it can be the accuracy measure of the clustering method that you are comparing with the true labels. But if you have two different clustering methods and you don't have the true labels, then it is basically the how similar the two clustering methods are in their outputs.
And as you said, it is the accuracy measure when it is a true level. So that can be compared with the accuracy also. I mean,
Yeah, in that case, it can be an accuracy measure if you know the true labels. So
it will be some generalized formula between RAND index and accuracy in that case.
yeah, it becomes like that. If you have the true labels, then basically in RAND index you are given two sequences and you compare these two sequences. So if one of the sequences is the true labels, then it becomes an accuracy measure of the other sequence which comes from a clustering method. And if both these sequences come from two different clustering methods, then basically the similarity of the two clustering methods.
Right. So I have one more. How we check on higher dimension, like clustering methods on higher dimension are checked on, like because most of them like gamings will also or DB scan. So I mean, if you can recommend also which works well with higher dimensions.
With higher dimension, all the algorithms would work. You are just visualizing it in the two dimensional plain, that's why you might get confused. But all the algorithms should work with higher dimensional data, 3D, 4-dimensional data, 5-dimensional data.
I'm saying which one will have the more accuracy than other.
I don't really know whether some algorithm is better than the others in case of higher dimensional data. It's more about how is the data set and what is the exact task based on that. So I mean, k-means would be very good if you know the clusters are of spherical shape. DB scan would be very good if you know that the clusters are based on the density of the points, and hierarchical clustering would be very good in case of most of the methods, most of the cases, I think. I'm not aware if any specific algorithm would be better than the others in case of higher dimensional data, but you can check in the internet if there is some information about that. Satyanarayan Rao says, in last question, what about complete link? Is it lower distance to be taken? So here we take, we will merge the two, in case of single link, we merge the two clusters by finding out the two closest points or two similar points. But in case of complete link, we will merge if the two most dissimilar points, if we have to find out for every pair of clusters, we have to find out the complete link distance, which is the similarity between the two most dissimilar points. Here we merged P4 with P5 and P6, because P4 is most similar with P5, so the distance or similarity we are using is between P4 and P5. But in case of complete link, I think we would use P4 and P6 in that case, because the P4 and P6 are the two most dissimilar points in two different clusters. So the similarity metric or the distance metric would change in that case. We would not merge 2 points, 2 clusters if the one cluster contains 1 point and another cluster contains another point, which are the most similar points left in that table. In that case, it would be exactly the opposite. So the similarity metric we will use between two clusters would be that the similarity between the two farthest points or the two most dissimilar points. So you can find out other examples of complete link in the internet also, of complete link clustering. So is there any other questions or doubts? So if there are no other questions or doubts, then
just
yeah.
In the assignment section, we don't have. We have given that you implement k-means, but the seed value isn't given. So I was considering it default 42 to implement the k-means. So they have in the assignment, if you check, it is given to use the some seed value, random state seed value. So in that only seed is given. So I used 42 as it is mostly widely used, but still I didn't get the accuracy as the 4 of the options out of that. So how I will
you can ask in the discussion forum. The regular TAs who have said the question for the assignments, they would be able to answer your question that what seed should be used to get the maximum accuracy.
I have pasted in the here in the chat also. It is just like A means cluster, N is 10. It's for the MNIST data set.
Hmm.
The random state is given as seed. Last time I have asked, so they have said you can use different, but
Yeah, I think if only seed is written here, that means you have to experiment with different seed values. I don't think seed value would matter that much. Wherever you start those centroids, it would eventually converge. It should converge if the data set is not very difficult to cluster. So you can try different seed values, and in most of the cases I think it would give good result. For with any seed value it might give good result.
but
Yeah,
how will I make sure? Okay.
yeah, the questions has been set by the regular TAs and the instructor, so we don't know about that. We don't know what set should be, a seed should be set here for the maximum accuracy, so you can ask in the discussion forum.
Right, understood.
Okay, thank you everyone. We will again have a live session next week.